We can
All right,
hear you.
that's good. Sounds good to you guys. All right, so I'm just gonna share my screen and let you guys know about next week. Basically, uh, next week test, right? So, all right, okay. So let me just go to your test. Okay, so this is basically. Uh, let me view as a student. So, all right. All right, so test 2 is going to be next week, and it's going to start March 13 at 12, as you can see in the screen, and it's going to be ended the March 16 at 12 p.m. Right? So 12 a.m. March 13 on Monday. The test is going to be opened, and it's going to be closed on Thursday, March 16 at midnight. Okay. So make sure you have this test. Basically, do the test. It has 25% of your grade. It's similar to test 1, and you have 90 minutes, only 90 minutes to do it. Okay. But before you do that, just go to mock test and then do mock test 2. Okay. So do a few mock test 2 so that you become familiar with test 2. Okay. Um, so test 2 is going to cover all the materials. So test 2 is going to cover all the materials which we learned from test 1 to now. So basically, all the materials which we learned from test 1 to now. So there are lessons, I believe it's lessons 6, 7, and 8, right? So that's going to be test 1, right? So that's basically the thing which you really need to prepare is just learn those material and then perform the test. So let me go through this weekly session and let you know exactly what's going to be covered. So after week 5, week 6 is going to be covered, week 7 and week 8, right? So these are the material which you need to prepare for test 2. So week 6 is future value and present value of annuity, simple and ordinary, general annuity and dual annuity. And for today material which we're going to cover today is going to be in your test 2 next week. Okay. So next week we will have a class, same as usual, but it's more question and answer classes. So just make sure you bring your question to the class so that we can cover those. Okay. In case you don't have any question, I can just go briefly on the material which we learned until now. Okay. So and then you can go ahead with the test. Okay. Any question? All right, no question. So yeah, one more thing I wanna emphasize is just the lab 6 and lab 7 need to be done as soon as possible, because lab 6 is going to be basically what you learned last week, and you have until March 12 to basically finish it. Lab 6 and lesson 6. Lab 7 is what we learned today. So you have until March 19. So next week you can do that. Okay. So this too also is important that you have to basically do it. Okay. Make sure you don't miss them, because if you miss them, then you're gonna lose marks. Okay. All right. If you don't have any questions, I can share my screen and we go from there. Okay. All right. Seems there is no question. I'm just gonna open my PowerPoint. Do you see the PowerPoint?
Yes.
All right. Thank you. All right. So today we're gonna discuss calculating periodic payment. So what is that? So basically, if you go to the equation of present value for basically ordinary simple annuity, we have present value equal to payment 1 minus 1 plus I power of minus n divided by I. Okay. Sometimes, so far what we've done with this annuity, they generally give us the interest rate, and they give us the period of time. They ask us for present value, and they also give us the payment. So they ask us for present value. In some questions, sometimes they ask you for what's amount of payment. So basically, they give you present value, they give you N, and they give you I. They will ask you for what's the present, what's PMT. Okay, so so now in this class, we're going to discuss, in this lecture, we're going to discuss how to calculate the payment. Okay. If the present value of annuity PV, the periodic interest rate I, and the number of payment period N are noun. So if this guy is a noun, if this guy is noun, and this guy is noun, okay, we can use the present value formula to solve the unknown PMT. So we can basically use this equation to find what's a PMT, right? So it's very easy. You know this. You know all these guys. So this guy PMT is going to be PV divided by the whole whatever it is here. So right, so it's going to be like that. So, and for the present value due annuity, also we have the same thing. So basically, if they give you present value due, the amount of that, also they give you the right hand side, which is this guy, and they ask you for PMT. So PMT is going to be this guy PV due divided by the whole thing which you have in the right hand side. Okay. So that's basically it. So you can basically calculate PMT if you have present value, if you have I, and if you have N. Okay. Just make sure if you're working with simple annuity, you can use I. But if you're using general annuity, make sure you use I2, right? So, and what was I2? I2 was 1 plus I power of C minus 1, and C was number of compounding period divided by number of payments per year, right? So the compounding, C is compounding frequency, basically of your interest rate divided by number of payment per year. Okay. All right. So what's present value? The present value generally, if you take a loan, if you put some money in your saving account and you're withdrawing it per month or per periodic time, if at the beginning you have some money, okay, and you're taking add from it as a loan or as investment, whatever. So this is this is a present value problem. But if you put money in the bank as an investment and you wanna withdraw it at the end of the annuity period, then it's going to be investment. It's going to be future value. Okay. So present value are all about loan and the money, any money that you put in the bank and you want to withdraw from it, right? So you want to know. So that's a present value problem. Okay. All right. Andre obtained 86,450 factory improvement loan from the bank. As soon as it's a loan, that you know that it's going to be a present value problem, right? From the bank at the interest rate of 15% compounded monthly. Are you provided with the FV, future value, or present value in this problem? Hint: remember, loan is equal to PV. Yes. Okay. So it basically give you the hint as well. Loan is equal to present value. So basically, you're dealing with present value problem. Okay. So because you get this loan and you have to basically pay it back, right? So that's a present value problem. Okay. All right, so let's solve that problem. Andre obtained a 86,450 factory improvement loan from the bank at the interest rate of 15% compounded monthly. Okay, what is the size of month's end payment required to pay off the loan in 12 years? Okay, month's end payment. Okay, so now this is basically an annuity problem. Why is an annuity problem? Because at the end of every month, Andre needs to pay. Do a payment for 12 years, right? So this is annuity problem. Okay. Now, which kind of annuity is this? First of all, as I said, we need to find which kind of annuity it is. Since it's month's end at the end of the month, so it's going to be ordinary annuity, right? And since the payment interest rate, basically 15% compounded monthly, basically the periodic, so for interest rate compounding period, right? So interest rate compounding period is monthly, right? Is equal to basically month's end payment. So since these are same as well, so it's going to be simple. So ordinary simple annuity, right? So this is ordinary because the end of the month, paid at the end of the month, and simple because the compounding period for interest rate is equal to payment period, right? So it's basically ordinary simple annuity. So now we know that this ordinary simple, then we need to use the equation for ordinary simple annuity. Okay. So what we're gonna do, we're gonna use basically, you have to find I, we have to find N, and we already have PV. We need to know, what's a PMT, right? So what is I? I is going to be J divided by compounding frequency, 15 divided by 12, right? So, and N is going to be the total number of payments. It's going to be 12 years multiplied by 12 months, right? So 12 months in a year and 12 years, 144, right? So first of all, 12 payment per year is going to be 12 multiplied by 12, which is going to be 144 payments. And then I is going to be, okay, so it doesn't say here I, but I is going to be basically 15% divided by 12, right? So which is going to be this guy, so 0.0125, okay? So now if you put it in the equation for present value, so we have present value 86,450. And we have interest rate, which we already calculated, 15 divided by 12. It's going to be this one divided by 100. And then also we have N, which is the total number of payments, which is going to be 144. We put in this equation. Now we have to solve it for PMT, right? So to solve for PMT is very easy. So you have the left side is already, you don't need to touch it. You have to calculate the right side. As soon as you calculate the right side, then the PMT is going to be left side divided by the right side. Okay, so that's going to be how it goes. So in another word, you can do that this way. But I would recommend you calculate the right side, and you have the left side and divide them together. Okay, so how do we calculate the right side? So let's go to the calculator. Let's calculate it together. Okay, so I want to calculate the right side. Okay, let me just go. Okay, we got some people waiting in the room. All right, so how to calculate the right side? Let's go to the calculator. Where is my calculator? Yes, here. Oops. Yeah. All right, so we want to calculate the right side, right? So we want to calculate 1 minus 1 plus 0.0125 power of minus 144 divided by this one. Okay, so first of all, we need to start from very the most anterior part, right? So so this is 1 plus 0.0125 is going to be 1.0125 power of minus 144. So 1.0125 power of 144 negative sign equal to, okay, so that's going to be this guy, the whole guy, 1 minus this number. So I'm going to store this guy and the number 1, and 1 minus recall number 1 equal to, so that's going to be the whole thing on the denominator. Now I'm going to divide it by denominator, which is going to be 0.0125 divided by 0.0125 equal to, so that's going to be the whole thing multiplied by PMT. Okay, so I'm going to store it as 1. Okay, so I store this guy, the whole thing on the right side as 1, and I have 86,450. So on the left, so PMT is going to be this guy divided by this guy, right? So I already store this guy, the right side on the calculator, 6662, right? So I need to divide 86,450 by that number. So let's do it, 86,450 divided by recall number 1, which is 66.2. It's going to be 1,297, okay? So 1,297.50 is going to be the payment which has to be done over 12 years to pay back the loan of 86,450 with the interest rate of 15%. Okay? Yeah, any questions so far? No question? All right. All right, let's do it in a calculator way, okay? Okay, so very important that you set the calculator to end, right? So let's do it in calculator way, okay? All right, so let me clear everything here in calculator. Make sure it's at end. Right now is on beginning, right? So BGN, right? So I need to set it to the end. So BGN, set enter, now is the end. So I quit. So okay, now there is nothing there. When there is nothing showing in your calculator, it means is on the end. When it shows when it shows BGN here and on top means it's in a due annuity. Okay, that's make sure that this is always is if you're working with ordinary annuity, make sure that the BGN is not showing up in calculator. Okay, this BGN which is faint on top of your calculator means this is due annuity. Okay, so let's go there. Second PMT now begins. So second enter. It's going to be end and then now quit. Okay, second quit. Okay, so now is end. Okay. So now that we are working for ordinary annuity, this is end already. And now let's put this stuff there. We just wanted to know what is the PMT, right? So now the unknown is PMT. So we have present value, we have future value is 0, right? So we have present value, which is going to be 86,450, 86,450, which is loan, so it's a positive sign. So it's going to be present value. We have the interest rate. It's going to be 15%. 15% is going to be interest rate. We have basically N, total number of payments. It's going to be 12 by 12, right? 12 years by 12 months. So it's going to be 144. It's going to be N. So I have this, I have PV. So I just need to set up the P over Y and C over Y. P over Y is 12, right? So because 12, you have 12 payment monthly, and C over Y is also 12, right? Because the interest rate component monthly is component monthly. So it's 12 and 12. I quit. Now the only thing which you need to know is PMT. I do CPT, PMT. 1,297.50, right? And why negative? Because you have to pay, right? You have to pay because you have to pay rather than receive. Okay, so that's it. So that's very simple with calculator. Yeah. Yeah. Any question? Any questions so far, guys?
Which week content are we on this week? 7. Just need a reminder.
What's your question, Vivian?
Which week of content are we on today?
Week 8. Here you go. Week 8 here. Week 8. Yeah, you see, calculating periodic payments. Yeah.
When did we start the lesson today? Like 11:40.
11:50. We start 11:50. So you were a little late. That's fine. That's fine. So we discuss okay. Two important things we discuss. First, your next week is going to be next week is going to be your test. Okay, so make sure you go to your test and do the test. Okay, this is very important, Vivian. So it's just 25% of your mark is going to be your test. So I'm going to show you again the test here. The test 2 is open at March 13, and it's going to be closed at March 16 and this time. Okay, so make sure you do the test. It's 25% of your mark is going to be this, and also the lessons and labs. So lessons and lab, lesson 6 and lab 6 and lesson 7 and lab 7. You need to do them as well. Okay, so these are important. You shouldn't miss it. Okay. And today we discuss how we calculate the PMT, right? So the payment. So let me just go a little bit briefly because for you guys who haven't missed the beginning of the class. So in some question we have some question they give you PV and they give you N and I. They ask you for PMT. So these are the questions which we are solving right now. So we basically we are targeting these questions which give you present value, interest rate, and the number of payments. So they ask you what's the payment monthly. So we basically isolate for PMT and find the PMT. Okay. And if it's this is basically simple annuity. If it's a general annuity, then this I is going to be I2, right? So the only difference between general annuity and the simple annuity is that the I is, you need to find I2 first, and then you use the same equation. So how do you calculate I2? I2 is going to be 1 plus I power of C minus 1, which C is going to be compounding frequency for your interest rate divided by number of payments per month, per year, okay? So that's going to be how we calculate the I2. Okay. All right. So let's go back to the question again. Yeah. So using calculator is going to be very easy to do that, right? So basically, if you know how to use the calculator, I think that these questions are going to be very easy to answer. Okay. All right. So another question, I will leave it to you guys. Give you guys 5 minutes to solve this. After winning a lottery, $10,300 is deposited into an account earning interest at 3% compounded annually. Okay, so this is deposited in an account and we will earn that interest. Okay, what is the largest withdrawal which could be made at the beginning of each month from this account for next 8 years? Okay, so basically you want to know. So first of all, this is a present value problem, right? Because you have say you have some money in the bank and you want to deposit, you want to withdraw from it, right? So it's going to be present value. So you have the value of your present value, right? And now which kind of annuity it is, because the beginning of the month is going to be due annuity, and because the compounded annually, right? So this compounding period is a year, but your withdrawal is monthly. So this is going to be general annuity. Okay, so this is compounding a year, and this is basically every month is going to be general. So general due annuity, guys. Okay, so I will give you guys 5 minutes for this.
Hi, Professor. What's the difference between today's content and before's?
What's that?
What is the difference between today's contents and the contents before? But I mean compared to last week.
Okay, okay, last week we discussed how to calculate the present value and future value, right? So this week we're going to discuss how to calculate PMT, right? The payment, right? So we discussed how now you have to know how much is the payment, right? Last week we discussed how to calculate present value. We know the payment, we know the other values, and then how to calculate present value and future value. Here we have the future value and present value. We want to calculate we want to know how to calculate payment, the value of the payment. Okay, so that's the difference. Let's see. Okay, so we got a lot of B here. Let's see whether the B is right. Yes, B is right. So let's go see how do you calculate it. Congratulations to you guys. How do you calculate it? Okay, so as I said, we need to find which kind of annuity it is, right? So is the beginning is due and then is general, right? Because the compounding period is different than your payment period, right? So to general due annuity. So the first thing which come to your mind as soon as you get the general annuity, you have to convert this I. This is J right now, right? So you have to convert the I to I2. Okay, first of all, you need to find what's I. So I is going to be J divided by compounding frequency. In this case, it's going to be 1, right? So because compounded annually, so that's going to be 0.03. That's I, and then you find I2. Okay, let's yes. Okay, so first of all, number. Okay, so I is going to be 0.003 per month, right? So okay, and then C. So what's going to be the C? C is going to be compounding frequency, right? So this guy compounding frequency is 1, right? So because it's compounded annually, compounding frequency 1 divided by number of payments per year. How many payments per year you have? 12 payments per year, right? Beginning of each month. So paying per 12. So it's going to be 1 over 12. So you have I, you have C. Now we need to find what's I2, right? So I2 is going to be 1 plus I power of C minus 1, right? So if you're wondering how to calculate this, it's 1.03 power of 1 over 12, right? So let's go do it in calculator. Let me just clear everything here, clear everything. And 1.03 power of 1 over 12, 1.03 power of, okay, 1 over 12. Okay, so open parenthesis, 1 divided by 12, close parenthesis, equal to. So that's going to be this, okay, minus 1. Okay, so that's going to be this 0.002466, right? So we know I2, okay? So find I2 now. So now we have to use the present value problem for do simple annuity, right? Because we already have I2, okay? So do simple annuity, we have the present value. This is the equation for that, right? We use I2 for that. PMT to present value do is PMT 1 minus 1 plus I2 power of minus n divided by I2 multiple 1 plus I2, right? So I use this. So now we have the left side. Left side is 10,300, 300, and we have the right side, right? We already calculated the I2, right? We have I2, we have N, right? What's the N? N is total number of payments. How many payments we have? 8 years multiplied by 12 months per year, which is going to be 96, right? 12 by 8 is going to be 96. So basically, okay, so we either can divide the whole thing by I2 and then use this equation, right? Or we can just keep the same equation and then find this guy, put this guy here, and and calculate the guy on the right, and then the PMT is going to be the guy on the left divided by the guy on the right, right? So that's the second way of doing it, okay? But anyway, so now we have to calculate this guy, okay? Knowing I2 and the N, okay? So it's going to be like this, okay? So let's do it together, okay? It's a little bit look complicated, but it's not that complicated, okay? So first of all, you make sure you go from the most interior part. The most interior part is this guy, okay? 1 plus I2, right? So let's go to calculator. So I2 is important. I'm just going to store it at number 1. So this is I2. And now I need to work with that, okay? So 1 plus I2 power of minus 96. So 1 plus recall 1, which is I2. Okay, now power of minus 1 is power of 96 negative equal to this guy. This is the guy. This is gonna be this guy in here. Okay. 1 minus this guy. Okay, so I'm gonna store this guy in number 2. Make sure don't overwrite on number 1 because number 1 is already your I2. You don't want to overwrite it. Okay, so store on number 2, and then 1 minus this guy. 1 minus recall number 2 equal to that's gonna be the denominator here divided by denominator, which is I2. So divided by recall number 1, which is I2 equal to this is gonna be the whole thing, 85 something. Okay, this is gonna be the whole thing. I'm gonna store it at number 3. Okay, I don't want to overwrite the other thing. So now I have to multiply this thing, the whole thing, by 1 plus I2 again. So and then multiply by open parenthesis 1 plus recall 1. Okay. Okay. So now I multiply this guy by that. Okay. So now I have the whole thing on the denominator. So the result PMT is going to be, so this is the 85.59 is going to be the whole thing in denominator. So and the PMT is going to be nominator divided by this guy. Okay. So I'm going to store this guy at number 4, and then nominator 10,300 divided by number 4. 10,300 divided by recall number 4 equal to 120. Okay. All right. 120.328. Okay. So that's going to be the result, the answer, which most of you guys were able to answer correctly. Okay. Yeah. Any question here? All right. So let's do it in calculator way. All right, it's general annuity due, right? So let's do it in calculator way, okay? So since it's general annuity due, the calculator needs to be set to beginning, right? So second, so this is the due annuity, right? So it has to go to there and set that to the beginning, right? So it has set to beginning and then come out. So second PMT, second set, and second come out, okay? So that's you make sure that the BGN is on top of your calculator, means that you're working with due annuity. Now put the stuff in there, right? So 10,300 deposited, so it means 10,300 is going to be your oops, sorry. Let me clear it. 10,300 is going to be your present value, right? And your future value is going to be 0, right? What's your interest rate? Your interest rate is 3% compound annually. 3% is going to be your interest rate. What's your total number of payments? Is 8 years multiplied by 12, 96, right? 12 multiplied by 8 is going to be 96, right? So it's going to be your total number of payments. So now you want to go to P over Y, C over Y, right? Number of payment per year, it's going to be 12, right? 12 payment per year, so it's 12 is right. So 12 payment per year. But number of compounding per year is going to be 1, right? Because you're compounding annually, right? So compounding frequency is going to be 1. So that's the only thing which you need to set properly. And then coming out, now you do CPT and PMT, you get $120. Yeah, and 20.32. So yeah. Any question? Any question, guys? All right. All right. So now that
do we just type all them in, and then I'm supposed to, and then I will find PMT. Is that what you've been
right. Exactly
talking about?
Yes.
Like last week. Just like last week. I mean, just like the content.
Yes, similar to that. Yes. So the other last week what did we do in the last week? We put everything there, and then we find PV. Last week we put PM over by N and whatever, and we find PV.
So this nothing new, like just
nothing new in terms of calculator. Yes, if you if you're good with the calculator, nothing. Okay, I would say nothing new, but yes, it's just nothing too much new. Yes, if you're comfortable with doing the calculator, is I would say nothing totally new, but this is just the thing which you have to cover, because it's just the payments, right? So you need to find what's the payment. Okay, so that's the difference which is new is we want to find payment rather than present value or future value. So okay.
Yeah. Professor, so is there any way that I can remind you to let me in when I click? Because today I was actually trying to join early.
Yeah, send me an email. Send me an email. Okay. When you come there and wait, send me an email. I'm gonna receive an email, and then I'm just gonna let you.
No, I was on time. I was quite on time.
Yeah, I know
okay.
you're always on time, but this time just if you wait for a lobby for more than a few minutes, just send me an email to remind me that I have to let you in. Okay. Generally, I assign one student for example, my tomorrow class. I have one student which she remind me and someone is a lobby, and I have to let them in. But in this class, I don't have anyone who does that. So maybe you want to do it from next week. You come earlier and then let me know who is in the lobby so that I can let them in. Okay, Vivian? From next week you do that. Okay. Just let me know who is in the lobby so that I can let them in. Okay.
Okay.
All right. All right. Let's go back to what we were discussing before. Okay. What we were discussing. Yes. Okay. So now, okay. The other problem is sometimes we have a problem that they give us the future value. Okay. They give a future value, and they give us the interest rate and the number of payments, and they ask us for what is the PMT. Okay. For the payment. So in that case, we need to use the future value equation. Okay. So similar to the present value that you use that equation to find the PMT, now we have to use the future value equation so to find the PMT. So they give you future value, they give you I, they give you N, and they ask you what is PMT. So what you can do is just put the stuff there, right? So put the future value there and calculate the right side. You calculate the right side, calculate the left side, and the PMT is going to be the left side divided by the right side, okay? Or sometimes it can be do, right? So it can be either an ordinary annuity or a general annuity, or the do annuity, okay? So if it's ordinary annuity, you know the equation. If it's do annuity, basically you know the equation, right? So for future value for ordinary annuity, you have PMT, future value is going to PMT 1 plus I power n minus 1 divided by I. And for future value for do annuity is going to be PMT 1 plus I power n minus 1 divided by I multiplied 1 plus I. You remember that? Do annuity has 1 plus I factors in front of it, okay? So if we know future value, if we know I, if we know FV, if we know I, if we know N, if we know all these three values, then we can calculate PMT, right? So PMT is going to be FV divided by this guy, okay? The whole thing, okay? Or for this case, for do annuity, PMT is going to be FV do divided by whole thing, this guy, okay? So that's going to be how we calculate the PMT, okay? And in the case that you have general annuity, so then you can't use I. You have to find I2, and as soon as you find I2, then you can put I2 here and then solve it for I2. Okay, so how do you calculate I2 again? I2 is going to be 1 plus I power of C minus 1, but C is going to be compounding frequency for your interest rate divided by number of payment per year, right? So that's the only thing which we need to do if it's not simple annuity, if it's general annuity, okay? All right, so Tyler paid a certain amount every quarter to save $50,000, okay? Wanted to save $50,000 in 15 years, okay? Since Tyler wants to save $50,000 in 15 years, then it's going to be future value, right? It's not going to be present value. Present value, you put the money in the bank and you want to withdraw from it for a certain amount of time, right? But future value is you put the money in the bank and you want to save it until a specific time in future. So that's the difference between the future value and the present value, right? So present value, you have some money in the bank, you want to withdraw from it until it's over, unless it's finished. Future value, you want to put some money in the bank and save it for a certain period of time. Okay, so that's the difference. Okay, so now Tyler paid a certain amount every quarter to save $50,000 in 15 years. Okay, wanted to save $50,000 in 15 years, so this is going to be future value. Money can earn 10% compound semi-annually. Are you provided with the future value or present value in this problem? Okay, remember, saving is future value. I'll give you the hint. So saving is future value. So it's going to be future value problem. Okay. So as a future value problem, let's see which kind of annuity is that. Is that annuity or not? Yes, this is annuity. Why? Because he's paying a certain amount every quarter, right? So every 3 months, he's paying some money. Okay. So that's going to be annuity. Okay. So because it's paying over 15 years, a certain period of time. Okay. So this is annuity. And let's see which kind of annuity it is, right? So is that due or ordinary? When it say every quarter, it doesn't say whether it's the beginning or end. It's going to be presumed that's going to be end. So it's going to be ordinary annuity, right? Every quarter, paying every quarter. It doesn't say whether it's the beginning or end. When it doesn't say, you always presume it's going to be end. So it's going to be ordinary annuity, and paying every quarter. And interest rate is semi-annually, so it's every 6 months. So interest rate, compounding period every 6 months, but his payment is every 3 months. So every 6 months, every 6 months. So it's going to be general, ordinary annuity, ordinary general annuity, right? So that's going to be the type of annuity we're looking at. Okay. So ordinary general annuity for this guy, as we discussed. And now as soon as it comes, the general come to your basically radar. You say, oh, this is general. As soon as general came, you have to convert this I to I2. Don't forget, guys, I to I2. Before you touch anything else, you need to convert the I to I2. So this is I. This is not exactly I. This is J, right? So J divided by 2 is going to be I, right? So J, 10% divided by 2 is going to be I. Let's go to the solution, okay? First of all, N is going to be the total number of payments, going to be 15 years multiplied by 4, right? Because you have every 3 months. You pay every 3 months for 15 years. So 4 payments per year multiplied by 15. So it's going to be 60 months, 60 payments. Now I is going to be J divided by M, right? So M is going to be 2, right? So M is semi-annually, right? So it's going to be 2. So 0.01 because it's 10%. Divided by 2, so it's going to be 0.015 per half year. So this is I. So now we have to calculate I2, guys, right? So as soon as general comes, as I said, general means you have to find I2. Okay. So for I2 we need C, right? C is going to be compounding frequency for your interest rate, which is going to be 2, right? Compounding frequency divided by number of payment per year, it's going to be 4, right? So how many payment per year you have? You have a quarterly payment, which means every 3 months you pay. So number of payment per year is going to be 4. And compounding frequency for your interest rate is going to be 2, right? So 2 divided by 4, 1 over 2. Okay, so now you have C, you have I, you find I2, right? I2 is equal to 1 plus I power of C minus 1. So you can do it in calculator very easy. 1.5 power of half, and then it's going to be this. Okay. So now let's do it together as well, because we need to go ahead with this guy. So I'm just going to do I2 1.05 power of 1 over 2 minus 1. Okay. So let's do it here in calculator. All right.
Sorry, Professor.
Yeah.
How did you tell which if it's pay at the end or at the beginning? Because I didn't see it in the question tells.
But when it doesn't say, okay, Vivian, can you just listen, please? When it doesn't say,
Yes.
when it doesn't say whether it's beginning or end, we always presume it's end. Okay. Right. It doesn't say. When it doesn't say, pay a certain amount of every quarter. When you say every quarter and doesn't say whether it's beginning or end, we always presume it's end. Okay.
Okay.
All right. Yeah. Okay. All right. So Okay, I2 is going to be 1.05 power of 1 over 2 minus 1. So let's do that in the calculator. 1.05 power of 1 over 2, which is going to be half, right? So half equal to minus 1. This is going to be I2. So I'm going to store it in I2 because I'm going to use it for my future calculation. So store number 1, okay? I2 is going to be store number 1. And now we need to use the equation for ordinary annuity because the payment made at the end of the month, and then use this equation, right? So divide by I2. So it's going to be 1 plus I2 power n minus 1 divided by I2. That's going to be future value. We can either divide it by this, or you can keep it at this, guys. You don't need to divide it like this. You can keep it on this. Put I2 there, put n there, find the value for the right side, and you have the left side as well. So the PMT is going to be future value divided by this guy. Okay, so it's just one way of doing is this. The other way is just divide the whole thing by this. This is going to be a little confusing, but it's okay. So PMT is going to be future value divided by this guy, right? So this guy multiplied PMT is going to be this guy. Now PMT, if you want to isolate the PMT is going to be a future value divided by this guy, okay? And now you have to put the stuff there, right? So you have I2 this, I2 is going to be this, and then you have to calculate this, okay? Let's calculate this in calculator together. All right, so let's do it in calculator together. So 1 plus I2 power of 60 minus 1. So first of all, we need to calculate the most interior one, right? So 1 plus I2 power of 60 minus 1. So this is I2, right? So 1 plus, recall 1 because we already stored it. This is going to be 1 plus I2 power of 60 equal to, okay, minus 1 equal to, so that's going to be the whole numerator here divided by denominator, which is going to be I2 divided by, recall 1 equal to, so that's going to be the whole denominator, okay? So the whole thing, $50,000 has to be divided by this guy, okay? So I'm going to store it number 2, okay? So $50,000 divided by number 2, $50,000 divided by recall 2 is equal to 371.61. Yeah. And if you round it, we can round it to 2-digit, 371.70, okay? And okay, so that's pretty straightforward, right? So that's pretty straightforward. And if you want to do calculator way, right? So if you're in a calculator way, make sure this is ordinary general annuity. So make sure on the calculator. So let me clear everything here. Okay. Make sure this is still BGN on top of my calculator, right? I need to set it to end. So it's BGN, set it to end, come back. Okay. Oh, someone asked me how to set the calculator to beginning or end. One more time. Second PMT. When I do second PMT, it shows end. So it means the calculator is is calculating ordinary annuity. If you want to make it do annuity, it's going to be beginning. So you do second, enter. Okay, so set it to beginning. Okay, second, enter, second, enter, second, enter, second, enter. You see, flip-flopping between beginning and end. Okay, so in this case we are end. Okay, so end and then second quit. Now the calculator is an ordinary annuity calculation. Okay, and if you want to make it do annuity calculation, do second PMT, it's going to be end, second enter, second quit. So now it's on the do annuity, and if you can just look at the calculator on top, it said BGN, means all the annuity are calculating based on the do annuity, beginning. Okay, so in this case we're not working with beginning, so I'm just going to go there, set it to end, and come back. Okay, so now if it doesn't say anything on the calculator, which means that we presume the annuity is ordinary, is not due. Okay, all right, so let's do this in calculator, as I said. Okay, all right, so now okay, so the future value is $50,000. Okay, so $50,000 is the future value. So it's gonna save $50,000 in future value. Okay, present value is 0, right? So because at the beginning of the time he didn't have any money, so he just want to put from the 0. He wants to accumulate this money over how many years? Over 15 years, right? So the present value is 0, future value $50,000, and now 10% compound semi-annually, so 10% is going to be I over y, right? So and then we want to know what's the n. N is going to be number of years multiplied by number of payments. So we pay quarterly. So I mean every 3 months. So it means the number of payment per year is going to be 4 multiplied by 15 years. So 60 payments. So 60 is going to be payments, right? 4 multiplied by 15, right? 4. It's going to be a payment per year multiplied by 15, 60 payments, right? So 60. So now we have this, we have this, we have that, and then now we have to go to P over Y and C over Y. So how many payment per year? As I said, 4 payment per year, right? Paying quarterly. So 4 payment per year. And what's the compounding frequency per year? In this case, compounding frequency per year is semi-annually. So compounding semi-annually means 2, right? So in this case, you have to set both P over Y and C over Y. Okay. When it's general annuity, guys, you have to set P over Y and C over Y, both of them. Okay. When it's simple annuity, P over Y and C over Y are the same. So okay. So quit. Now we have set everything right. You need to know what's the PMT. CPT PMT 371.69. Okay. Yeah. So that's how to do the calculator mode. Okay. Yeah. Do you get it, guys? Any question? Any question here? All right, no question means that everyone is good with this. So so we can take a break now. We go because next topic is gonna be we're gonna discuss something different, totally different. Okay, so we can take a break and come back at let's say 12:55. So let's take like a 15 to 20 minutes break, and then we come back and discuss the rest of the topic. Okay, guys. Any question? Any question before we leave? All right, no question. Then let's see you guys at 12:55. Okay. All right. All right, guys, welcome back. All right, I'm just gonna share my screen again. Any question, guys, so far? One more thing, I just want to emphasize one more time, guys. Next week is gonna be your test 2. Vivian, everyone else. Next week is gonna be your test 2. Okay. Make sure you don't miss the test 2. Okay. If you miss it, you're gonna lose 25% of your mark. I'm just gonna share my screen and show you the whole structure for test 2. All right. So the test 2. It's gonna be, you can see my, okay, you can see my screen though, right? Can you guys see my screen? Yes?
Yes.
Yes?
Yes.
Yes. All right. So test 2, you see guys, test 2 graded is opening March 13, closing March 16, open at 12 a.m., which is gonna be basically midnight, right? So open the whole March 13 is gonna be available, and it's going to close on March 16, 11:59. Okay, so you have 3 days, 4 days, right? March 13, 14, 15, and 16. So you have 4 days to do this. The same structure as the other test. 90 minutes, 25% waiting time. You have only 1 attempt. Before that, you can do mock test 2. So mock test 2 is very similar to test 2, but it is not graded. So you can basically try it many times and then do it. So right now you can try my mock test 2 as well right now, because we already passed March 6. So you can after this class you can try a few mock test 2, and then if you're comfortable, just go for the test 2, right? So don't wait too much time. Okay. Next week we're gonna have basically the next week we're gonna have a question and answer basically session. So bring your question to the class. If you don't have any question, then we can probably go to the probably I can have an overview for whatever we learned in past few weeks, and then we basically go for there. So if you don't have any question for next week, but try to go through the course material and find your question. So find some question, and if you find something difficult, bring it to the class, and we will discuss this. Okay. So that's going to be next week agenda. But yeah, so next week is going to be your course. Make sure also do the labs as well, like lab 4, lab 5, sorry, lab 6 and lab 7s. These are lab 6 and 7s. Lab 6 is going to be due to March 12th, right? So you have only 4 days to finish lab 6 and lesson 6, and then lab 7 and lesson 7 is going to be March 19th. So you have 11 days for this as well. So make sure you do these guys, because these are also important. These are coming toward your final grade. Okay. All right. So if you don't have any question, I'm gonna hop on my PowerPoint. Any question? All right, no questions. So let's. I'm just gonna share my PowerPoint. Do you see this?
Yes.
All right, sounds good. All right. So now in this section, we're gonna discuss how to calculate the number of payment and time period. Okay. So far, again, we go to the same equation. If you go to the same equation, future value for basic future value for ordinary simple annuity. If you go for the equation, right? So far, we learned how to calculate the future value if we know PMT, I, and N. We also know how to calculate PMT if we have FV, I, and N. Now there is one more trick. We want to calculate. We want to know what's going to be the N. Okay, so what's going to be the N? So now in this course, in this lecture, we will say we will have future value. Also, we have PMT, we have I, but we don't have N. So in this lecture, the n is unknown. Basically, the number of payments is unknown, and also the time period is unknown. So basically, how do we calculate that? It's simple, right? You need to isolate for n in this equation. So you need to get rid of everything which is with n. Okay. So first of all, you divide FV by PMT and then multiply by I, so that you keep that 1 plus I power n. Okay. So let me do this. Let me do this in the paintbrush. Actually, that's the best one. Okay, let me just go there and then do it in paintbrush. I think that's the best paint. Okay. So what's the equation? FV equal to PMT 1 plus I power of n minus 1 divided by I. Okay. So FV equal to PMT uh, 1 plus I power of n minus 1 divided by I. Okay. So what you want to know what's I, right? So I is going to be, so you want to know what's going to be the n, right? So first of all, we need to isolate for n. So if I multiply f by I and divide by p, so it's going to be, so and then so it's going to be okay, f multiplied by I divided by p is going to be what? If the f divided by p multiplied by I is going to be 1 plus I power of n minus 1, right? So now I want to isolate for n. I want to isolate for n. Okay, so f I divided by p plus 1. So okay, so it's going to be 1 plus I power of n is equal to fi divided by p plus 1. Okay. Now I get the natural logarithm from both sides to get rid of to put the n basically, to keep the n basically on the instead of being in the power to be in the multiplier, I do the natural logarithm from both sides. Okay, so it's going to be n natural logarithmic of 1 plus I. Yeah, because natural logarithmic of 1 plus I power of n is going to be n times natural logarithmic of 1 plus y, right? So equal to natural logarithmic of 1 plus fi divided by p. Then n is going to be natural logarithmic of 1 plus fi divided by p, fi divided by p divided by natural logarithmic of 1 plus I. Okay, so that's how we basically isolate for n. So that's how we isolate it for n. So if you go there, that's the same thing. 1 plus I fv divided by p divided by 1 plus I. So that's how the formulation came from for this guy, right? So that's basically how the formulation came from this equation to find what's the n. Okay, so n is going to be natural logarithmic of 1 plus I multiplied fv divided by pmt divided by natural logarithmic 1 plus I. So your basically your tests are open book, so you have all this cheat sheet and formula. That's fine, you don't worry about that. But that's how this is the thing which I show you here is how you calculate it from this equation. How do you isolate n? Okay, from this equation, how do you isolate n to find n? Okay, knowing that you know I, you know FV, you know PMT. So if you know all these three components, then you can find N. Okay. So let's go through this thing. Okay, with FV, N can be calculated by rearranging the future value of ordinary simple annuity using natural logarithm. Okay, so that's how do you do it. And if in case that that your annuity is not simple, your annuity is general, make sure you use I2, guys. If your annuity is general, then you have to use I2. Okay, and then how do you calculate I2 again? 1 plus I power of C minus 1. Okay, so C is going to be compounding frequency divided by number of payment per year. Okay. And same for present value. So if you have a present value and you wanna calculate N, you have present value, you have PMT, and you have I. You wanna calculate N. N is gonna be using this equation. Okay. Same way I did for future value. You can do it for present value. So you can basically isolate 1 plus I power of minus N, and then you use natural logarithmic, and then you do the same equation. So to find what's the value of N. Okay. Okay. So after you find N, okay, after you find N, then what's going to be the time period? Time period is going to be number of payment per year multiplied by the time in a year. So time in a year is going to be N divided by number of payment per year, right? So in case that the question asking you what is the time in a year, you need to divide the N which you find in the previous equation by number of payment per year. So then you'll find what's going to be the time in the year. Okay. All right. So let's do a question here. Okay, if money can earn 18% compounded monthly, how long rounded the next payment period will it take for the funds in the RSP to grow to $385,000 based on the annual year-end contribution of 3,200? Okay, so all right, I'm gonna solve this equation with you guys because it's the first question after we learn the equation. So and then we leave it to you for the next one. Okay, so all right, so what's the question here? Okay, if the money earned 18% compounded monthly, okay, so money earning this amount compounded monthly, so how long it will take rounded up to the next payment period? Okay, next payment period will it take for the fund in an RSP to grow to $385,000 based on annual year-end contribution of 3,200? Okay, so the question here is you're putting money in your RSP, okay, same as everyone else. Okay, just make sure. So something good about RSP, guys, is just is important that you contribute to that because it also help you in terms of tax benefit. Also help you guys also. So this is something good. Like as a Canadian, you need to really think about your RSP as soon as possible. So you will have an account there and contribute to that. It helps you a lot. Okay, so so RSP, you said he's gonna put if the money we're gonna put the money there for 3,200 every year, right? So we're gonna put the money 3,200 every year, and he's asking how long it's gonna take for the money to grow to $385,000. Okay, so that's the question. Okay, so this is going to be a future value problem, right? So it's not present value. You're not putting any money in the bank and withdrawing from it. Okay, so that's the future value. So this is the future value. Okay, and now we want to know, is it the annuity or not? Yes, this is annuity. Why? Because we're doing year-end contribution of 3,200, right? So every year we do a contribution of 3,200, so that this is annuity. Is it the due annuity or ordinary? This is ordinary annuity. Why? Because we do year end, right? We don't do beginning of the year. The end of the year, we contribute to 3,200, right? So it's going to be basically ordinary. And let's see if it is a general or it's a simple annuity. So since we are contributing every year, but our interest rate is compounded monthly, so it means that it's a general annuity, right? So So it's general, ordinary general annuity, and we have the future value of that. So it's a future value problem. So we need to use the future value equation. Okay. Let's go for the solution. So as I said, it's ordinary general annuity. Yeah. So we need to basically, since it's general, you see guys, as soon as you see the general, you have to find I2, okay? You have to find I2, okay? So that's, since it's general, you definitely need to find I2. So I2 is going to be 1 plus I power of C minus 1. So C, how much is going to be? CC is going to be compounding frequency for your interest rate. It's going to be 12 divided by number of payment per year. It's going to be 1 payment per year. So it's going to be this. And this is going to be this. Okay, so let's do it together in the calculator as well, because I wanna keep it as well. Clear. And now we have 1 plus I power of C will become 1.015 power of 12 minus 1. So 1.015 power of 12 equal to minus 1 equal to, so this is going to be 0.19. So this is going to be basically I2, right? So 1.19 is going to be I2. So I'm going to store in 1. Okay, so it's going to be I2, and then now we have to use the equation for n. Okay, so we want to know how long it's going to take. Means how many. First of all, we need to know how many payments going to be done, right? So how many payments is going to be done, and then divided by payment per year is going to be number of payments. Okay, so how long it's going to take? We're going to use this equation. Okay, so this equation for n. We can either do that or do this, guys. Okay, so if you're more comfortable with the way which I paint here, let me make another payment, make another one. So okay, okay, so you can either do that or stick with the original equation. Okay, stick with original equation here, which is going to be this equation, not this equation, this future value equation. So stick with this equation. Okay, so let me just put the stuff there in this equation. Okay, so let's see. It's like future value is going to be P, and then we have 1 plus I power of n minus 1 divided by I, right? So that's going to be future value problem. Okay, now let's go back to the same equation, and we have I2, right? It's not I, it's just going to be I2, right? So it's going to be I2. So this is I2, okay? The whole thing is going to be the same, but it's going to be I2. And now we have the money, the future value grow to $385,000. So I put 385,000, right? So it's going to be my future value equal to payment, which is 3,200, right? So 3,200 open 1 plus I, 1 plus I2 in this case, right? I2 0.1956, 0.1956 power of n, which is unknown in this case, minus 1, right? Divided by 1956, okay? So now we can isolate for n in this equation, right? So if you don't want to learn the original equation, we can isolate for n. So how do you do it? You divided this guy by 3,200, multiply by this, and then you do ln, and then do this the whole thing. Okay, so that's one way of doing it. The other way is just memorizing the equation. So it's up to you guys. You can just memorize the equation or just have it in cheat sheet. You have I2 now, you have FV, you have PMT, and you use this equation. So let's do it together here actually. So let's do this here. Okay, ln 1 plus point this, like I2 multiplied by FV divided by PV, PMT, ln 1 plus 1. Okay, so let's do this together. Okay, okay, so first of all, we need to find the most interior part. So I2 FV divided by PMT. Okay. So recall 1, this is I2, right? So we already have I2 stored in number 1 actually. So this is I2. And then now I2 multiplied by FV, okay. I2 multiplied by FV, which is 385,000 equal to, okay, multiply by 3,200 divided by 3,200 equal to, okay, so it's going to be 23. That's going to be this guy plus 1 equal to, okay, so this is the whole thing in front of ln, okay, so you need to get ln of this guy. So this, we have this, now ln of this guy. So okay, so it's going to be 3.2. I'm going to store it at number 2, guys. Don't forget, don't put on the store at number 1, because number 1 you already I2 there, right? You don't want to overwrite I2 because you already have in number 1 you already have I2. You don't want to overwrite it, okay? So store at number 2. So this is going to be the whole nominator, okay? And what's in the denominator? ln 1 plus I2, okay? So recall this guy, I2 plus 1 plus I2. Now we get ln of this guy, ln of this guy, okay? So that's going to be denominator. So this is this is denominator, okay? So I store it at number 3, okay? So recall number 2, which is going to be nominator, okay? This guy divided by recall number 3, which is going to be denominator, equal to 17.91, okay? So 17.91 is going to be the number of, so it's going to be the number of payments, okay? 17.91 is stupid, right? Because that doesn't make any sense, right? So it has to be 18 or 17, right? So it has to say, when it said next payment period, means you have to make it 18, okay? Right? Because it's stupid, because the number of you calculate the number of payments, right? Number of payments can't be integer, right? Can be decimal, because you're looking at the numbers, right? So 18 contribution, which means the last contribution be a little bit smaller than 3,200. It's going to be a little bit smaller, right? So because it was 17.90 or something, right? So last contribution is going to be a little bit smaller. So 18 contribution, and then yeah. So and then you have 18 contribution, which means not that. So it means that when you have 18 contribution, then you need to divide this the n, the number of contribution, by the number of payment per year, right? So the n divided the number of payment per year, in this case is 1, so it's going to be 18 years, okay? So n is number of contribution, guys. Don't forget it. This is number of contribution. It's not number of years. You have to divide it by the number of payment per year to be able to basically find the number of years, okay? Okay. All right, so let's do it in calculator mode, because I know you guys are very interested in calculator mode. It's much easier to calculate in the calculator mode than by hand and all those cheat sheet and formula. So let's do it in calculator mode as well, because the beauty of it is that you can solve all your question in the test too using calculator. So I don't want to make you guys lazy to not learn the equation and formula, but that's something you can do. So I give you the guys the option to use the calculator rather than the formula and cheat sheet. So okay. So anyway, so let's do it in calculator method. So all right, first of all, we need to know which kind of annuity it is, right? So we set the calculator right. So it said basically end, so it's going to be year end. It's going to be ordinary, and then it's going to be general, ordinary general annuity, right? So ordinary, okay. Okay, so let's go to calculator. Since it's ordinary, then means I don't need to get, and so this has to be end, okay. So ordinary, okay. And now we have to put the stuff there. $385,000 is going to be future value. $385,000 is a future value, right? So future value after you save the money, and then yeah, you made the payment of 3,200, right? So So 3,200. Make sure guys have negative sign, right? So payment. And then present value is 0, right? Because you start from 0, right? You start from 0 and you start to sum up, save until you get to that $385,000 mark. So now 18% is going to be your 18% is going to be your basically your interest rate, right? So interest rate is 18%. And now you want to know what's the end, right? So so now you put this, you put this, you put this, you put this, you don't know end, right? So the only thing which you need to set is P over Y and C over Y. So what's a P over Y? Payment per year. How many payment per year you have? Only one payment per year. So it's going to be only one. And compounding frequency for this interest rate is going to be 12, right? So per compound monthly. So it's going to be this. And now you quit. Okay, so I said everything now. Just need to know to all right. Okay, so someone is in lobby, huh? No, it's not in lobby. Why is it me? Okay, anyway, so everything set, and I need to just do CPT and N 17.91, guys. You see, 17.91. So it's much easier to use calculator than the than the formula, but I don't know. It's just up to you guys. You just calculate it easy, but just make sure that you said everything right. Okay, so 18 contribution, 17.91. As I said, it doesn't make any sense because n has to be a number, right? So because we want to know how many contribution, how many payment you had, how many payment you have. You can't be 17.5 payments, right? You want to know, is it 17, 18, 19, 20, whatever? So just give us a number. So that's why you have to round this number to the nearest payment, the next payment. When it's a next payment, means that you have to go up. When it's a previous payment, you have to go down. And if it's a rounded, then you have to round it. So in this case, it's a next payment. Next payment, you have to go up. So it's going to be 18. Okay. So 18 years. So it's going to be 18 years. Okay. All right, so okay, so we have the same if annuity is due, right? So if it's due annuity rather than ordinary annuity, we have another 1.I term in front of future value and present value. And for finding n, it's basically the same concept. You basically use the same equations to find n, to isolate for n. You just have a 1.I term basically at the denominator here. Okay, so that's because it's going to be the same, basically the same process, but you have just 1.I term here. Okay, it's going to be like this. And as I said, if it's general annuity, then basically you need to you need to find I2. Okay, so make sure anytime it's general, guys, you need to find I2 and then use the equation. Okay. That's important, okay? And if it's present value annuity, basically, if you have present value and due, it's going to be this equation. And if you want to isolate for n again, so you presume that they give you basically the present value, they give you payment, and give you I. You just want to find n, and it's going to be using this equation, okay? And the process was very simple, as I explained it to you. You try to isolate for n, you get rid of everything in front of n, and then you use natural logarithm to get rid of this 1 plus I, and then n is going to be like this, okay? And then one more time, just make sure that the I is I2 if you're working with general annuity, okay? All right, guys. And now let's go solve a problem here, okay? I will leave this problem to you guys. I give you more than 5 minutes. I would say 7 minutes for this, because if you want to use the equation, you might need more time. But if you want to use calculator, you might have less time. But I'll give you 7 minutes. Oscar won the lottery of $38,000, and he deposited the money in an investment fund earning 6.4% compounded quarterly. If he were to withdraw the $2,000 at the beginning of every 3 months, how long, rounded to the next payment period, would the money last in the fund? Okay, so first of all, which kind of problem it is basically the problem is present value problem, right? So This is the present value. He put it in the bank. He will put it in the bank, and withdrawing it every 3 months at the beginning of the 3 months. Okay, so it's the present value. This is the present value. So which kind of annuity it is? It's beginning. It's going to be due annuity. And then is it simple, or is it general annuity? 6.4% compounded quarterly every 3 months, right? Compounded quarterly compounding period is every 3 months, and he withdraw every 3 months, so it's going to be simple. So it's do simple annuity with present value. Okay, so that's the problem. Okay, so now we want to find n, the number of payments, and then also how long it takes. How long it takes means when you find number of payment divided by number of payment per year, it's going to be how long it's going to take per year. Okay, so I give you guys, as I said, 5 minutes. You have time to 1:30 to solve this equation, this question, guys. Okay. All right, I can see some answers here. D, all right. See whether D is right. Yeah, D is right. Good for you guys. All right, so okay, so first of all, we need to find which kind of annuity is this, right? So as I said, the payment is at the beginning of the month, right? So if we withdrew if he were to withdraw $2,000 at the beginning of every month, so it's going to be due, right? It's a due annuity, right? And every 3 months, and it's every 3 months, and the component quarterly, right? Component every 3 months, so it's going to be due simple, right? Due simple annuity, okay? And is it the present value problem or future value problem? It's the present value because he put the money there and he's withdraw from it, so you have to use the present value equation, right? And we don't need to find I2 because it's simple, right? So if it's general, then we need to find I2. If it's simple, we don't need to find I2. So the I is going to be I2, okay? So so we go to the equation. Equation is going to be n minus, so it's the present value due, right? So we go to present value due equation right here, present value due equation. So it's going to be n equal to minus ln 1 minus I multiplied PV due divided by PMT plus I 1 plus I divided by ln 1 plus I. Okay, so we use this equation, present value due. Okay, and then we just put the stuff there, right? So okay, so we put this stuff there. So it's going to be I, which is going to be 6.4 divided by 4, right? Because it's compound quantity, right? 6.4 divided by 4, right? So it's going to be 0.106, 0.016, sorry, multiplied by PB due, which is $38,000, divided by PMT, 2,000, 1 plus I, divided by L plus 1 plus I. Let's do this together, okay, in the calculator. So I is going to be 0.1. Okay, so let's do it in calculator together. All right. So okay, how can we do it? We just go for the most interior part. So we find nominator, we find denominator, and then 1 minus this guy. Okay, so let's do this from the top. 0.016 multiplied by $38,000. 0.016 multiplied by $38,000 is going to be 608. Okay, so that's going to be nominator. I'm going to save it, store it at number 1, save it. Okay, and now I have this denominator, 2001 plus 0.016, so it's going to be 1.016, right? 1.016. This is going to be the inside. Multiply by 2,000. Multiply by 2,000. This is going to be denominator. Okay, so nominator. So this is denominator. Store at number 2. Okay, so I have nominator store number 1, denominator store number 2. Okay, so you're going to recall 1 divided by recall 2 is equal to, that's going to be this number. It's going to be the whole thing. It's going to be this number. So I'm going to store it. I don't need 1 anymore. So I store at number 1. Okay, so I stored the whole thing at number 1. 1 minus this guy. Okay, so 1 minus recall 1 equal to this guy. So that's going to be the whole thing here. And I need to get the ln from this. Okay, so ln of this guy, ln of this guy. Okay, so I'm going to store at number 1 again. Okay, so that's going to be the whole nominator. The whole nominator is here, and stored at number 1. Okay, and now denominator 1 plus 0.016 ln. So 1.016. Okay, and then you get the ln of this guy. Yeah, and now I'm store this guy at number 2. Okay, so I have store number 1 divided by store number 2. Okay, so recall number 1 divided by recall number 2 equal to, that's 22 with negative sign, and I have to get rid of negative sign because they have negative, right? So it's going to be 22.3999. Okay, so now so as I said, we want to know number of payments, right? So we can't just give, you can't just say 22.3999, right? So we need to round it up to the next payment period, okay? So how do you round it? So it's going to be 23, right? 22 is going to be 23, yeah? Round up to next payment period, okay? So 22 is going to be 23, okay? Because we can't say like he paid 22.39. That doesn't make any sense, right? So I said 23 payment, 24 payment, 22 payment, whatever. So 23 payment, okay? 23 withdrawal, okay? And now we want to know how long it's going to take, right? So we want to know what the 23 withdrawal is going to be, how many years, right? So the withdrawal is done every 3 months, right? So let's do this, okay? So every 3 months, so it's going to be the 4. So every 4 payments, we're going to have 1 year, okay? So we have 23 payments. So 23 divided by 4 is 5.75 years. So that doesn't make sense, right? So you need to put 0.75 years to the months as well, right? So 0.75 multiplied by 12 is going to be 9 months, okay? So it's going to be 5 years and 9 months. Congratulations to you guys. That you answered this equation correctly. So okay, any question here, guys? Any question before we go to calculator method? All right, so calculator method. So let's do it in calculator method, okay? So let's set up everything in calculator now. Let's clear everything, clear everything, clear everything, clear everything. So Oscar won the lottery of $38,000. Okay, so $38,000 is going to be present value, right? So $38,000 is going to be present value, okay? And then he's gonna take the money out of it until it's finished, right? So it's gonna be over, right? So so future value then is gonna be 0, right? And he withdraw $2,000 at the beginning of every month. So withdraw $2,000. So $2,000 is gonna basically withdraw, right? So withdraw. So it's gonna be, since it's a withdraw, it's gonna be PMT, right? So PMT is gonna be positive, right? Since it's withdraw, okay. If it's basically payment, has to be negative, but if it's withdraw, it has to be positive. Just make sure that you guys know about it, okay. Now okay, so let's go to the rest of it. So sorry, it has to be negative though, right? Yeah, payment has to be negative because you withdraw money, okay. So yeah, so 2,000 is negative. Yeah, present value. So I set up present value, PMT, and future value. Okay. So I over Y 6.4%, 6.4% is going to be I over Y, and then now I have to go to. So I need to know what's the end, though, right? But we need to set up the P over Y and C over Y. P over Y, payment per year. How many payment per year we have? 4 payment per year, right? So it's quarterly. So 4 payment per year, and C over Y. And compounding frequency is going to be 4 as well, right? Because every is quarterly, yeah. So it's going to be 4 as well because it's simple, whatever you call it. So now I said everything. Now I need to watch. Just want to know what's the n, right? So n is going to be 22.83 as you find it here. Oops, what did I do mistake? What? What? I made a mistake somewhere. That's interesting. Okay, let me redo it. Okay. 22.39. Let me redo it again. So what did I do mistake here? Okay, let me just clear everything. So okay, one more time. $38,000 is gonna be loan. Present value $2,000 is gonna be payment with negative sign. Future value is gonna be 0, right? 0 is gonna be future value I over Y 6.54%, right? 6.4% is going to I over Y, and P over Y is 4, C over Y is 4 as well. So come on, right? So P over Y is 4, right? And C over Y is also 4. Okay, so I've come out in 2000. That's everything is right. And now what's the N? Okay, so there is some problem here. I think
you haven't set the beginning mode, is it?
oh yes. You're right, you're right, you're right. Oh yeah, beginning of everything was. Yes, you're right. Yes. Thank you very much. Thank you very much. Yes.
Okay.
All right. So yeah. So yes. So yes, it has to be beginning. Yes. Thank you very much. Yeah. Yes. So it's beginning mode. Yes, as you said. Yes, it's beginning mode. Yes. Beginning of every month. Sorry, guys. Yeah. So yeah. Yeah. So now let's do it one more time. $38,000 is gonna be present value. $2,000 is gonna be the negative sign payment. Future value is going to be 0. 6.4% is going to be I over Y. And then now P over Y is 4 and C over Y is 4 as well, right? That's right. Okay, so and then also beginning. CPT on N, yes, 22.39. Thank you very much. Yes. Yeah, thank you for taking into account this one. Yeah, so 22.39, now it's going to be 23 withdrawal. And now you have to divide it by 4 to get the number of years, 5.75 years. And 0.75 years, you have to convert to months. It's going to be 9 months, okay? All right, so one more question, guys, and I give you a few minutes for this as well. Go Travel Inc. invested $56,000 in an investment fund that is growing at 5.6% compounded semi-annually. If Go Travel wants to withdraw $4,300 from this fund at the beginning of every month, how long would the money last in the fund? Round up the next payment period. Okay, so this is basically another present value problem because he put the money in the bank and withdraw it every month. And then which kind of annuity is this? Is due annuity because beginning of every month, and it's basically general, right? Because the compounding period is semi-annually, but your payment is every month, so it's going to be general, right? So general due annuity with present value problem, and we want to know what's the N, right? So what's the N? So okay, so I give you 5 minutes for this as well. All right, I'm back. Okay, so B, got another B. Okay, let's see what the B is right. All right, let's see. Oh, yeah, perfect. Yeah, you guys are smart, huh? Very smart. Okay, so let's go for the solution of this. Okay, so first of all, which kind of annuity is this, right? So first of all, we need to know. So the beginning of every month, which is going to be due every, and then the compounding period is going to be semi, but the payment is going to be monthly. So it's going to be due general, right? Due general annuity, and is the present value problem or a future value problem? Invest the 56,000 and withdraw from it until it's finished, right? So it's basically at the beginning you put some money there, and you take money out of it until it's finished. So it's going to be present value problem. Present value due general annuity. Since it's general, we need to find I2 first, right? So since it's general, I2, guys, I2. General, I2, right? Find I2, then you can use the equations, okay? I2, and then use the equation for finding N from do general, basically do annuity. Present value do annuity, find N, right? So use N from present value do, using that equation, knowing I2, okay? So first of all, I2, I need to find I2, okay? So I2 is going to be I, which is this guy divided by 2, right? So this guy divided by compounding frequency. 5.6 divided by compounding frequency is going to be 5.6 divided by 2 divided by 100. It's going to be this guy, 0.028, power of C. C is compounding frequency, which is going to be 2, divided by number of payment per year, number of payment per year, which is going to be 12, right? So 2 divided by 12 minus 1. Okay, so it's going to be this. It's going to be this. So basically, it's going to be this. Let's do it in calculator. I want to keep that number in my calculator. So let me do it in calculator as well. So 1.028 power of 1 over 6 minus 1. So this one more time. 1.028 power of 1 over 6. 1.028 power of open parenthesis 1 divided by 6 close parenthesis equal to, okay, and then minus 1 equal to this guy. So this is basically I2. I stored number 1. This is very important. Don't overwrite it because you want to use it for the rest of the equation. So this is I2 stored number 1. And now, as I said, we need to use present value due, right? So because the present value is a due annuity, and we need to use I2, and then we need to find N. So we just open the cheat sheet or formula sheet. N is going to be ln 1 minus I2 multiplied by I multiplied by PV due divided by PMT plus 1 plus I divided by ln 1 plus I. So this is the equation you open when you open your equation book or equation sheet. Just you need to know which one you have to use, right? So that's the art, basically the art, and your logical thinking has to tell you which equation you have to use. Okay, so first of all, you need to use present value and the do. Okay, present value and the do. Okay, so then you use the present value and do equation. Okay, so we learn quite a lot of equations, right? We learn present value without do. We learn future value do. We learn future value without do. Like we have 4 equations for N. You have 4 equations for N. You need to know which one you have to use. So the one right now for this guy, you have to use present value and do. Make sure you have to use I2 as well because the general annuity is not simple annuity. Okay. So now let's go sort this. Let's sort this then. Okay. So the same process that we did with the other guy, we need to do it here as well, right? So I need to basically find, so ln of this guy divided by this guy. First of all, we need to go most interior part, which is going to be this guy, okay? So let's do this guy first, and then go there. So ln of this guy, okay? So this is the denominator. So it's 0.00446 multiplied by 56,000. So I2 multiply by 56,000 equal to, so that's going to be the denominator here, right? I'm going to store it at number 2. Make sure you don't store on number 1 because number 1 is your I2. You need your I2 everywhere, okay? So store number 2. And now the denominator is 1 plus I2 multiplied by 4,300. So 1 plus, recall 1 because it's I2. Okay, so it's going to be this guy multiplied by 4,300 multiplied by 4,300 equal to, so that's going to be denominator. So store at number 3. Okay, so I have this guy, the top guy on number 2, the bottom guy on number 3. So number 2, recall number 2 divided by recall number 3 equal to, so that's going to be the whole thing. So this guy divided by this guy. So okay, it's going to be the whole thing. The whole thing is going to be this. So I'm going to store at number 4. Okay, so 1 minus recall 4 minus recall 4 is going to be, the whole thing in front of ln. The whole thing in front of ln is going to be this guy. Okay, now I have to get the ln of this guy. So that's going to be this, and I'm going to store it at number 5. Okay, so store at number 5. Okay, so the whole thing is a number. So the whole nominator, it's stored at number 5. Now I'm going to go to the denominator, 1 plus I, right? 1 plus I2, ln. 1 plus recall 1 equal to, and then you have to get the ln of this guy. Yeah, so it's going to be denominator. Store it at number 6, right? 6. So recall number 5 divided by recall number 6 equal to, so that's going to be, this guy divided by this guy, and there's a negative sign in front of it. So sorry. So 13.39. Okay. Yeah. So 13.39. Okay. You see. And now, I said round it up to the next payment period, right? So 13, as I said, 13.39 doesn't make any sense, right? So you want to know how many payment you made, right? You can't say I made 13.39 payment. Everyone laughing at you, right? So you have to really make it to the next, round it to the next payment, right? Or they round it to the previous payment. You have to look at the question. Question sometimes tell you round it to the next payment, or they say round it to a previous payment, or or just run your answer. Okay, so just look at the question. The question is the next payment. Okay, so it's going to be 13.39. has to be 14, right? So it's 14. Now we want to know how long the money would last. 14 payments, right? 14 payments, and you do payment every month, means 1 year and 2 months, right? 1 year, 2 months. Or you can do that, right? Yeah, you can do that. Yeah, but 14 payment every month means 1 year and 2 months, right? 12 months is going to 1 year and 2 more months, right? 1 year and 2 months. Either that one, or divide 14 by 12, and then 1 year plus that the residual, multiply by 12 again, and it's going to be 1 year and 2 months. Okay. All right, so let's do it in calculator method as well. Make sure that the BGN mode is on, so because I was forgetting that last time. So yes, the BGN mode is on right now. The BGN mode is on right now. So $56,000 is going to be your present value, right? This is a present value problem, right? And now withdraw 4,300. 4,300 is going to be withdraw with the negative sign. Make sure the sign for the PMT is different than the sign of the PV. Yeah. 5.6%. 5.6% is going to be compounded annually. Yeah, and then future value is going to be 0, right? Oops, sorry guys. Future value is going to be 0. 0 is going to be future value because you take the money out of it until it's finished. So future value is 0. So I set everything except the P over Y and C over Y, right? So 5.6%. Yeah. So okay. So let's go to the P over Y. How many payment per year you have? You have 12 payment, 12 pay every month. And how many? What's the compounding frequency for your interest rate? It's 2, right? So 2 is going to be compounding frequency, and then I get out. So now I set everything. Okay, set everything. I just want to know what's the end. So CPT and N. So it's 13.39, guys. Yeah, so it's going to be 14 withdrawal, which is going to be 1 year and 2 months, right? So that's how we solve this. Okay. All right. Any question, guys?
Yes, sir.
Yes.
Yes, sir. In this, it shows the negative, the PV as the negative and not the payment. Is it okay if PV is negative and the payment is the positive?
Yes, yes. Make sure the signs are different, okay? Make sure the signs are different, okay? sign for PMT has to be different than the sign for PMT. Okay, sign for PMT has to be different than sign PV, and so for same for future value. So if you put the future value, also you need to make sure that the sign for future value is different sign and your PMT. Then you're gonna be right. Okay.
So when it is a withdrawal, the PMT is usually a negative sign.
Yes, that's right. Yes, yes. So if let's try it with positive sign, see what we're gonna get. Okay, let's try with positive sign. Okay, let's try with positive sign. All right, so I'm just gonna clear everything. See what we're gonna. So let's just try with positive sign. So let's go for the same equation. $56,000. $6,000 is gonna be your present value, and PMT is gonna be 4,300. I'm not gonna change the sign. PMT. Okay. Future value is going to be 0. Yeah. I over Y is going to be 5.6. 6 is going to be I over Y. And P over Y 12 and C over Y is going to be 2, right? So that's the same thing. I quit. And you see? And it's minus 12.61. Doesn't make sense, right?
Yes.
So it means that you have to back in time. You have to go 13 back in time. Instead of going future, pay 13 payment, you have to go back in time and pay 13 payment backward in time rather than forward in time. So it doesn't make any sense, right?
All right. Thank you, sir.
You're welcome. All right. Any more questions, guys?
Yes. So with the T end up 1.16, where we choose between the multiply question provide 1 year and 2 months and 1.17 years. So what if they're both right? What do we choose?
Okay, so I think your question is that if you run this, right? If you put 1.6666, you make it 1.17, right?
Yeah. So the question is B or D, because the 1.16 years.
Let me see.
D,
Let me see.
right? 1.17.
Oh yeah. So you see, round up to the next payment period. That's important. To the next payment period. Okay. So 1.17 year doesn't make any sense though, right? So because you want to pay every month.
Right. Yeah. Yes. Yeah.
Right. So 1.17. What the heck is that? 1.17 year. Say every month. You want to run it to months. You have to give it a month. 2 years, yes, 24 months, right? 14 years is like whatever, 140 months, right? 1 year and 2 months is 14 months, right? 1.17 year. What does it mean? Right? What does it mean? Doesn't make any sense, right? You want to round it to months. Round up to the next payment period. Yeah?
Yeah. Thanks.
Makes sense? Makes sense? Yeah. All right. All right. That was a good question, Vivian, actually. That was a good question. Very good question. All right. So any other question, guys? Any other question? All right. So if there is no question, guys, just make sure one more time, please go do your test 2. If you don't do it, you're gonna lose the score for that. Okay. Go do the test 2. You have the time for that. Do the mock test a couple of times before you do that, and then also lab 6 and 7. You have to do it as well. One more thing I'm gonna say: we will have a class next week. We're gonna go through questions and answers. And if you don't have any questions, and I'm gonna prepare for an overview of whatever we learned in the past 4 weeks. Okay. That's all I can say. I would say so. If Ying, you want to talk? You want to say something?
Yes. So about my lab 5, I don't know. Did you submit the mark about my lab 5? Because I go to the grades, the part, right? We can see our grade, right, in the black row. I see my lab 5 is 0%.
Oh yeah. So okay. So this question people ask me many times. So your updated marks are in Vereta. Okay. So I haven't imported from the marks from Pareto to Blackboard for a long time. I think like at least 2-3 weeks. I haven't imported anything from Pareto to Blackboard. But as soon as you finish your test 2, I'm gonna import the result of your test 2 and the labs from Pareto to Blackboard. So right now, the most updated marks are in Pareto, and all the time, the Pareto is the most updated marks. So if you see marks in Pareto, that's gonna be your mark, okay? But Blackboard, don't rely on it too much because I haven't imported it yet. So I have to import your marks from Pareto to Blackboard, which I haven't done it yet. So I'm gonna do it after your test 2, okay?
Oh, okay, thanks.
You're welcome, Ying. Any other question, guys? All right. So I wish you guys good luck for the test then, huh? I hope you can do very well in the test. So, and drop me a line if you have any question there, okay? All right, guys. If you don't have any question, we can call it off.
Okay, bye.
Bye.